All right, pre-calcers, welcome back to the lesson 6 on the binomial expansion, binomial theorem. So now we're going to work through the examples. If you were listening to part 1, hopefully you have taken my advice, which is to try to go through each of these examples and set them up yourself, see what you're able to do. Math, of course, is not a spectator sport, and we will not be testing you on your ability to copy this down, rather on your ability to understand and demonstrate that understanding. And so if you have not yet attempted these, please take my advice and go ahead and attempt them before just copying down the answers. Okay, so what we're going to look to do here is, in this case, we've been asked to do the entire expansion. Of course, we've got the one option, which will be to write out each of the parentheses and distribute. Probably you'll be thinking that's about the same amount of time as I might take to write out each of these. And so what I'm going to do is focus on the setup, and then I'm going to skip a couple of steps and go straight to the answer. Okay, and so first of all, a couple of key things. This now kind of represents A and this represents B in the context of the explanation I gave you in the first part. Here we have got an exponent of 4, which means we're expecting 5 terms after we have expanded out the binomial. All right, and so what we can do is we can set up for each of the terms 3 sets of parentheses. This is one of the ways I think about this. The first is the combinatorial number, which is going to account for the coefficient. In this particular case, that's going to be 4, I beg your pardon, 4 choose 0. And then the next term will be 4 choose 1, 4 choose 2, and so forth. And so what you're going to start to see are some patterns here. Hopefully you're going to start to see the key patterns. And so we've got our parentheses for each of the terms: 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. What you'll see is that for combinatorial numbers, if you were paying attention when we connected these to the to Pascal's triangle, is that you would have noticed that there is symmetry involved, and so 4 choose 0 and 4 choose 4 produce the same numerical value. Likewise, 4 choose 1 and 4 choose 3 will produce the same number, and so forth. Okay, this parenthesis over here is going to have the A term in it, and so what you should also hopefully remember is that the first term in the expansion started with the highest power and then decreased. So 3, 2, 1, and 0. And so we could then insert in the place of A, of course, this is 2x. And so what you can see immediately, of course, is that Pascal's triangle gives us only this first number here, where the terms inside the parentheses themselves have got numerical values or coefficients other than 1. Those are being raised to powers, and that's going to affect the overall coefficient. So we need to take that the coefficient into account and then multiply by the numbers from the terms contained within. All right, and so for the second term of here, our B, our exponents are going to go from 0 increasing until we reach 4. The other thing to take into account, very common error, is to write 3y. Of course, we want to include the sign of that term, and so we need to be inserting minus 3y. So in this case, we've got some cleaning up and calculations to do to save a little bit of time. What I will do is I'm just going to pause the video for a moment, and then I'm going to write out the answer just to jump things ahead. All right, and so there we have our final answer for the expansion. All right, what I'll do in this one is just show you how to use the calculator a little bit. And so now we just need to pay attention to what the question is asking. So in this case, we've been asked for the last 3 terms of the expansion, power of 8. So there's a total of 9 of those terms. And so again, I'm going to just start by setting up my parentheses for each of those three terms. We'll fill those in, and then I'll just show you a little bit on the calculator, and then we'll be able to go from there. And so the other thing you need to be aware of, if it's the last three terms, is the combinatorial numbers and how those are going to work. So for the last term, we are of course choosing from 8, and that's going to be 8 choose 8, which means this is 8 choose 7 and 8 choose 6. And so the last three terms are in fact the 7th, 8th, and 9th term, because remember, if the exponent is 8, then there are going to be n plus 1 terms, which in this case is 9. And so this is the 7th, 8th, and 9th term. The very first combinatorial number is, of course, 8 choose 0. Okay, so we have that. The rest is relatively standard stock. We have the 2x and the y. In this particular case, again, we need to take into account that here we're going to end with y to the power of 8, which means the 2x is going to be to the power of 0. And from the end of the sequence, working backwards, power of 7, power of 1 in this case, power of 6, and power of 2. And then we can fill those in, and then we can work this out. So what I'm going to do very quickly is just to show you how to work out the numerical value of 8 choose 6 on the calculator, or 8CR. And so on your calculator, either through the calculate menu or a new document, existing document, doesn't really matter. I'm going to open up a new document with a calculator. I'm going to go to menu, and one of your options is probability. One of the probability options is combinations, and there we have NCR. And really what we need is the two pieces of information: what is N and what is R. In this case, we are choosing from 8, and there are 6 items that we're choosing in probability terms. That's going to yield the numerical value of 28, which of course must then be multiplied by 2 to the power of 2, which is going to be 4, x squared, y to the 6, and then we've got a little bit of cleaning up to do as well. Okay, same as before. I'm going to pause, and then we'll have the answer up there. You go ahead and try and work it. All right, and so there we have our answer. Hopefully that corresponds to what you got. All right, and so what we'll try to do for these is I'm just going to focus on setup again, and I'll go through the setup of the next, 1, 2, 3, 4 examples, and then I'll pause the video and then just write in the answers for you. Okay, so this time we're focusing on the 4th term. The thing that you want to watch out for is just to remember, if it's the 4th term, the first term starts with a power of 7, but in terms of the combinatorial numbers, the first term is always n0, the second term n1, the third term n2, and so forth in terms of our combinatorial numbers. And so those are going to increase, and then when we finally reach the last term, of course, it will be n choose n. So keep that in mind. When we're looking for the 4th term, we're really looking for NC3 in the setup of this problem. And so in this case, the n happens to be 7. So it's 7 choose 3 because that it starts at 0. The first term is a squared. It's going to be power of 0, power of 1, power of 2, power of 3. And the second term minus 2a, and it's going to be to the power of 4. And again, look for the key pattern here, that the sum of those two exponents will always add up to the original exponent, which of course is the same as the number of options from which we are choosing. So that's our setup, and then it's just a case of evaluating. All right, example number 4, find the coefficient of the x to the 5 term. And so in this particular case, instead of giving you a specific term number, they're really giving you information about which exponent to use for the term containing the x or x's, and then we can figure out the rest from there. And so in this case, I can begin by putting minus x over 2, because that's our second term. 4 is going to go in here. We know that our combinatorial number is going to be choosing out of 9, And then in order to get x to the 5, hopefully you realize that this term would need to be to the power of 5, which means this would need to be to the power of 4. And we could have 9 choose 4, or in fact 9 choose 5, because of the symmetry of the numbers. It wouldn't make any difference. Okay, we'll jump ahead to example 5. Now we have a more interesting variation of the previous question. We have been asked for the constant term. So this would be the term that only has a numerical value. It has no variables. And so we're going to have no variable in this case. And so what we're looking to do is to get the term that will cause these two to cancel out. Okay, and so let's start with the setup over here. So what we can do is we can say we know that we are choosing from 6. There are going to be 7 terms. We're choosing from 6. We know that the first term is x squared. We know that the second term in the parentheses, not to be confused with the second term in the expansion, the second term in the parentheses is minus 1 over x. And then we need the combination of exponents here that will cause the positive exponent to match the negative exponent. Of course, denominator is going to have the negative exponent to cancel out. Okay, in this particular case, if we raise this to the power of 4, that'll give us 1 over x to the 4. That will also lead this to be 2, because 4 plus 2 must equal 6. That will yield this as x to the power of 4. Those x's will cancel, and that will lead to a term with no variable, and i.e. a constant term. And then the last piece, of course, is to say 6 choose 2, or indeed we could also have 6 choose 4. Okay, final setup of the last example. And again, just variations on a theme. And what you need to do is focus on what information is given. So one term in here is our expansion. We are given the term that has a very large coefficient, and we have to determine the numerical value of the term in the binomial, or the second term in the binomial parentheses. And so what we're going to do is follow the same procedure in terms of setup, paying careful attention, of course, to the x to the power of 4. This term here has no x, and so that gives us the clue that we need, which is to say that this has to be x to the power of 4 in order to produce an x to the 4th term. That means that a will be to the power of 6. It also we know for sure that that has to be 10 because of the exponent, and we know therefore that that is 10 choose 4. That is equal to 3,281,250 x to the 4. The x to the 4s will cancel in this case because we're solving for a, and we will then be able to figure out what a is. Very much a calculator question. We're not expecting you to divide a number in the millions by another very large number. Okay, and so hopefully that makes sense in terms of setup. Go ahead and work those. Hopefully you set them up yourself, and I'll write up some answers. All right, so here we go. We've got example 3's answer over here. If we scroll down, here is example 4's answer. Jumping ahead, example 5, the answer is 15 is our constant term. And in example 6, after a little bit of work and rearranging, a is equal to 5. These are answers only, not showing working, just so that you're able to double check if you were on the right track. There will, of course, be a completed detailed key posted in Google Drive as usual. All right, good luck on your assignment. Please do not work backwards from the answers. We do not give you answers to the assessments in advance.